Okay, back to the cladogram. Recall that we are looking at the marginocephalia, the organisms that have a extension of a bony frill from the back of the skull. We talked briefly about the Pachycephalosauria, but now we're going to look at a bigger group, the Ceratopsia, which includes a lot of dinosaurs that you may be more familiar with. So again, here's the complete dinosaur cladogram. We go to the more detailed marginocephalia cladogram, and there's the defining node, the Ceratopsia, and it is going to include this Psittacosaurus, this one little branch over here. We'll talk about that briefly. And then all of these other things up here. And notice we've got nodes defined in great detail here. We've got the Neoceratopsia, the Ceratopsidae. Here's a different family. And then here's a couple of other things that we're going to call subfamilies. So it's going to become very confusing as far as taxonomic names, but then the naming of areas of the cladogram, nodes of the cladogram too. So bear with me, but you still got to know it. So first of all, Psittacosaurus, what is it? It's unique. It's known also as the parrot dinosaur, and it's from the early Cretaceous of Asia. And look, for dinosaurs, it's actually kind of small, about 2 meters in length, but it has this parrot-shaped face. The rostrum, I guess you'd say, the front end of this looks like it has a biting beak that a parrot might have. Interesting group. Notice it points to the so-called frill, very, very small. If you could say it's there at all. This is why it's kind of a group that's hard to place. It did have what's called inset cheek teeth and pouches. Now look at this. How do we explain this? We're going to see this again several times. So there's the cheek teeth. For you, you have cheek teeth too. Those are your molars. And notice that your cheek teeth, your molars, are pressed right up against the edge of your face, your cheek, because you have your bony projections of your face, your skull, right above it. So there's not much space between there, unless you stick a bunch of food in your mouth and then you chew it. Well, these things, the way their skeletons are built, they have bony extensions of the upper part of the skull and the lower part of the skull, such that the cheek teeth, the molars, are inset. And without even sort of stuffing the face and chewing it, there'd be a huge cavity. If you just had flesh or scales or something draping straight down, a huge cavity on either side of the face here, so that they could process large amounts of food in short amounts of time. Interesting group. It's usually sort of a common feature that we're going to see for herbivorous or plant-eating creatures. They need to get a lot of chow in and chew it up and process it that way. Other things, they are clearly bipedal creatures, the same evidence as before. The rear legs, the hind limbs, are much longer than the forelimbs, and we have such beautiful specimens of these things. We have some that are preserved with gizzard stones. Very much like chickens or other birds today, they will literally swallow stones such that they're placed in their gizzard, and it helps them grind up or pulverize their planty food that they're eating. So several bits of evidence suggest this was a plant-eating creature, but look at these artists' reconstructions, shown as very ferocious, fierce. You'd think this was a creature that was about to eat you if you saw it. The thought is that this is all sort of defensive posturing, sort of to scare away potential predators, to interact, male-on-male combat or territorial disputes, whatever. But again, look at the different reconstructions and colors. So there's the actual bones, and here's the artist's reconstruction on these things. Well, that's the Psittacosaurus. Now I want to look at the next node on the cladogram. These are all of the other ceratopsians. So we've named that node for everything else. and it's going to include a couple of different families. So first we have this family Protoceratopsidae. And once again, these are all late Cretaceous from Asia, but we do have some in North America as well, basically northern hemisphere. And these were sort of medium-sized dinosaurs, 1 to 3 meters in length total, a big skull, and a big frill. So we're starting to see these dinosaurs that have this huge plating at the back of the skull that we think of for ceratopsians. The forelimbs and hind limbs roughly the same length, so it probably always walked on all fours. And for this group, the Protoceratopsians, they don't have horns. Small nostrils. Perhaps there's a sexual dimorphism. Here's the first time I've talked about this, meaning if we have lots and lots of specimens of a particular group, and we find that about 50% of them have one shape or size, and 50% of them have another shape or size, for a lot of fossil work, we assume that they are males and females, that there's a dimorphism. You'll have usually more robust males and more gracile or fragile or smaller females. So you can see the two pictures here. Perhaps one of the things that these are famous for is the fact that Roy Chapman Andrews, remember we talked about him, the Beloit paleontologist, swashbuckler, is one of the persons that helped discover these things in herds, but also nests with eggs. So the first conclusive evidence that dinosaurs laid eggs, Protoceratops. First conclusive evidence that they nested those eggs, that they put them in a circumscribed region, Protoceratops. And then herding, traveling in groups. We find these things in such abundance where we have males, females, we have adults, teenagers, juveniles, babies, and eggs. So aspects of behavior. And so here you see some pictures of the fossils of these things. So on the lower right, there's an actual skull, and you can see the frill here. It's not a solid piece of bone. Remember, the more bone you add, that's heavy. That's a huge, heavy mass to carry around. And so one way is to build this big frill, but have it with these prominent holes or fenestra in them, but still with skin draped over it, as shown with this artist's reconstruction up here. And then the lower picture is the fossil or image of the way the museum has laid out how the fossil eggs were actually found. And notice again, these eggs weren't just sort of plopped in there and let sit there scattered randomly, but they've been actively placed and arrayed in this radial pattern. Again, all aspects of sort of parenting behavior or an advanced level of behavior. So not just laying eggs and leaving, covering them up and leaving like some reptiles do today, but active sort of caring or nurturing of these eggs. Kind of interesting. The family Protoceratopsidae then is contrasted with the family Ceratopsidae, and this is starting to get into groups of dinosaurs that we all know very, very well. These things are only found in North America, and we've had over a century now of our paleontologists describing them. And these were huge, so large, 4 to 8 meters, huge, huge skulls. Look at the size of this skull. If you go from the tip of the snout to the tip of the frill, and if you laid it on end, it's clearly as long as the actual body of the organism. Also, look at the nose area of the face. Huge, huge nostrils. So that's an eye hole, that's a nose hole, very, very huge. And here we're going to learn of a separate taxonomic category. So remember, families have the family, the name, and then the last 4 letters are IDAE, Ceratopsidae. we sometimes need to subdivide these families, and rather than create a new category, we just call it a subfamily, and those are going to have an ending of INAE. So the family Ceratopsidae has two subfamilies, and one of them is the subfamily Pachyrhinosaurinae. And again, this is sort of a North American, US and Canada type thing, but we find these things all the way up to the Arctic Circle in Alaska, which we're going to talk about later here, that there's some dinosaurs that clearly were way up there in the high latitudes, so they were having to deal. Even in a very warm world, it would still be very cold up there, and it would still be very dark up there for the winter months. And so these pachyrhinosaurs, these are one of these groups that we find in this Arctic Circle area. Look at this. It has a frill, but it's a shorter frill compared to the other ones we're going to see. And then also, these things have horns. So remember, Protoceratopsidae, let's go back here. Protoceratopsidae, like Protoceratops, did not have horns. It had a frill, but it doesn't have horns. Ceratopsidae has horns, but it has two different subfamilies, and the first of these, this Pachyrhinosaurinae, is defined by having a nasal horn, a horn over the nose, that is much larger than the horns over the eyes. So, horned things are family Ceratopsidae, but we subdivide them into whether they have a huge frill or a small frill, and then I guess an easier thing to look at is the length of the horns. And so here's Pachyrhinosaurus. Again, artist reconstruction above, the bones below. We do have evidence of herding or grouping behavior for these as well, and some really wonderfully full and detailed deposits in Canada. Again, vegetarian, lower area here. This one you can't see as much, but here you can see the nasal horn is much larger than the eye horn. This is then contrasted with the subfamily Ceratopsinae, which have a huge skull, and the frill is enormous. It is larger, as long or larger than the rest of the skull. And it has eye horns that are bigger than the nasal horns. And the classic example is the beautifully classic, wonderful dinosaur. It's a favorite of a lot of people, the Triceratops.